In this video, we will be solving a system of linear equations using Gaussian eliminations and Gauss-Jordan eliminations. We will start with Gaussian eliminations. In solving Gaussian eliminations, we have three steps to follow. We first find the augmented matrix, meaning we need to write the augmented matrix of the system. Okay, we need to take out all the constant and numerical coefficients of our variables. Second is row echelon form or REF. We need to use elementary row operations to change the augmented matrix to row echelon form. So what is the structure of row echelon form? So in the right side, you have there the leading coefficient there, 1, and the lower matrix, all zeros. Step 3, back substitution. We need to write the new system of equations that corresponds to the row echelon form of the augmented matrix and then solve by back substitution. Start with our illustrative example, then solve the system of linear equations. You have there 4x plus 8y minus 4z equals 4, and 3x plus 8y plus 5z equals negative 11, and negative 2x plus y plus 12z equals negative 17. Again, for step 1, we need to find the augmented matrix of the system. So you have therefore A, negative 4, and then 3, 8, positive 5, then negative 2, 1, 12, we have there 4, negative 11, and then negative 17. Then we need to close our matrix. Now let's proceed to step 2. First thing to do is to make this entry equals 1. We need to formulate an elementary row operations. Okay, from that, we can have this, our row 1 as 1/4 r sub 1. Okay, to make this quantity become 1, we need to multiply this 1 by 1/4. 1/4 times 4 will give us 1. 1/4 times 8 will give us 2. 1/4 times negative 4 will give us negative 1. And then separate them from the constant. Then 1/4 times 4 will give us positive 1. Okay, so the rest, the row 2 and row 3 will just copy. So and then our next goal is to make this entry become zeros. So then we can have, or we can formulate an elementary row operations R2 minus 3 r sub 1 and implies r sub 2. Okay, so whatever the results of r sub 2 minus, the second is to make this negative 2 equals 0. Then we can make this as r sub 3 plus 2r sub 1, and that will be put in r sub 3. Okay, for row 1, we'll just copy. Then for r sub 2, we'll use the elementary row operation. So just like a substitution in algebra, it is 3 r sub 2 minus 3 r sub 1, which is 1, will give us 0. So that's our goal actually, no? To make this entry equals 0. And the rest will follow, no? Then for the next entry, 8. So that's r sub 2 is 8 there. 8 minus 3, our r sub 1 in this column, which is 2, then times 2, that will give us positive 2. So you write there positive 2. And then the next entry, 5. So 5 minus 3. And in this column, we have there the r sub 1, which is negative 1, times negative 1. That will give us 5 plus 3 equals 8. So we'll write here 8. Then the last entry, negative 11. Negative 11. So negative 11 minus 3 times the r sub 1 in this column, which is positive 1. I'll use 1, and then negative 11 minus 3 is negative 14. So you will write there negative 14. So r sub 3, which is negative 2, that's negative 2, then plus 2r sub 1 is 2 r sub 1, which is 1 in this column, right? And then that will give us 0. That's our goal actually in making this elementary row operations, to make this entry equals 0, and the rest, okay, it's up to the result. Then that is 0, 5, 10, and negative 15. So next thing to do, since we already have this entry 1, 0, 0, and next is to make the leading entry again equals 1 here in the second column. We'll multiply the row 2 by 1/2. We'll just copy the row 1, 1, 2, negative 1, then positive 1. And then for row 2, we will multiply it by 1/2. 1/2 r sub 2. Okay, when we multiply 1/2 r sub 2, and that will give us 1/2 times 0 is equals to 0. Then 1/2 times 2 is equals to 1. And 1/2 times 8 will give us positive 4. And 1/2 times negative 14 is negative 7. And the new entry for row 2 is 0, 1, 4, and negative 7. For row 3, we'll just copy. Okay, so since we already have this entry equals 1 in row 2, in the leading entry, the next step is to make this entry equals 0. Okay, to do that, we'll make again another elementary row operation. Okay, for row 1 and row 2, we'll just copy, and for row 3, we'll make an elementary row operation to make this into 0. Okay, how to do that? So simply we'll use the leading entry equals 1. Then sub 3, that is minus 5 r sub 2. And make sure to put row 3 or r sub 3. Entry in row 3, 0. Then minus 5 times 0 in row 2, there. That is equals to 0. Yes, here is 0. The next is 5. We have 5 minus 5 times 1 equals 0. Okay, 5, then minus 5, R2 is 1, so will give us 0. And then, you have there R sub 3 is 10. 10 minus minus 5 times r sub 2, which is 4, that is equivalent to negative 10. Okay, so here is negative 10, and the last entry in row 3 is negative 15, minus 5 times r sub 2 in this column, that is negative 7. So multiply by negative 7. That would be equals to positive 20, since it's negative 15 plus 35. So that's positive 20 there. Thing to do is to make this entry negative 10 into 1. Okay, since we need to make our leading coefficient equals 1. For row 1 and row 2, we'll just copy. And then for row 3, we'll make, again, an elementary row operations in which we will multiply this row 3 by negative 1 over 10 r sub 3. So then that will give us negative 1 over 10 times 0 is 0. And negative 1 over 10 times 0 is R3. So negative 1 over 10 times 0 is 0. Negative 1 over 10 times negative 10 equals 1. And negative 1 over 10 times 20 will give us negative 2. So this is now called the row echelon form, or REF. So what's the basis? The leading entries are ones and the lower matrix are zeros. We now have an equivalent matrix in row echelon form, and the corresponding system of the equation is, so there. So we already have the value of our z in this form. So we can now use back substitution to solve the system. So solving for y in terms of z, since we already have the value of z, we are going to use the equation 2 now to solve for the variable y. Okay, so you have there y plus 4z equals negative 7, and we know that z equals 2 there. So y plus 4 times negative 2 equals negative 7. Okay, so then that will give us y plus negative 8 equals negative 7. The property of equality, then we have here y equals negative 7 plus 8, or will give us y equals positive 1 there. So this will be the value of our y, this will be the value of our z, and we'll now solve for variable x. We'll use this equation 1 here, x plus 2y minus z equals 1. We'll just copy x plus 2y minus z equals 1, and then substitute the values of y and z. That will give us x plus 2 times 1 minus negative 2 equals positive 1, and that will give us x equals 1 minus 2 minus 2. Alright, so then that will give us x equals negative 3. So that will be the value of our x, y, and z. So therefore, the solution of the system is the ordered triple of negative 3. We'll write first the value of x, negative 3, 1, and negative 2. And this is our final answer. And that's it on how to solve using the Gaussian eliminations.